Hello everyone, welcome to Learn Online. Today will be our fifth session on trigonometry. In our previous session, I had already told you that we'll be dealing with maxima and minima in today's session. But then, before we start solving maxima and minima problems, I would want you to know all the important formulas that we use in trigonometry. So in today's session, we'll first quickly revise all the formulas that we have studied in our first session. And then, we'll also be seeing other important formulas that would be required for us to solve the problems based on trigonometry. What are the important things that we discussed in our first session? First, we saw the sign of each and every ratio in different quadrants. First quadrant, all the signs were positive. In second quadrant, sine and cosecant were positive. In third quadrant, tan and cot were positive. And in my last or fourth quadrant, cos and secant were positive. We saw this in our first class. We also saw for 90 degrees and for 270 degrees, the values for sine, cos, tan and all those changed. How did it change? We could write sine of 90 plus theta as cos theta, or sine of 90 minus theta was also equal to cos theta. Similarly, cos of 90 plus or minus theta was equal to sin theta. And this was the same for tan as well. Tan of 90 plus or minus theta was equal to cot theta. Similarly, cot of 90 plus or minus theta was equal to tan theta. I am writing down all the values for 90 degrees. But then this not only holds good for 90 degrees, it also holds good for 270 degrees. Now coming to sign of all of these. Sign meaning plus or minus. What did sign depend on? The sign of these were dependent on initial position. Initial position of the ratios. So what are the other important formulas that we saw? We saw the trigonometric identities. Which are those? The first trigonometric identity that we saw was sine square theta plus cos square theta is equal to 1. Which was the next identity? Next identity was the most important one. You take stars for this. This was the important identity that we saw. Which was that? 1 plus tan square theta was equal to secant square theta. We also derived few more identities. But then which is the important identity that we derived? We derived secant square theta plus tan square theta is equal to 1. Secant square theta, sorry, this is secant square theta minus tan square theta is equal to 1. But then it is of the form a square minus b square. This could also be written as a plus b into a minus b. So what did we write this as? We wrote this as secant theta plus tan theta into secant theta minus tan theta. So this was also very important. And then, which is the other identity which we saw? The other identity was 1 plus cot square theta was equal to cosecant square theta. These were all the important identities that we saw in our first session. So pause the video here, quickly copy this down. Once you are done copying, we'll be looking at other important identities as well. I hope you have all memorized the formulas that we wrote down till now. We'll be looking at other important formulas now. Which are those? So pay attention to these formulas. We'll be using these formulas to derive much more formulas. Which are those? Sine of a plus b. Sine of a plus b is equal to sine a cos b plus cos a sin b. Again, the other important formula is sine of a minus b. that is equal to sin A cos B minus cos A sin B. So which is our next important formula? Next important formula will be cos of A plus B. That would be equal to cos A, pay attention here, cos B minus sin A sin B. You have cos of A plus B, you will get a negative sign here. For cos of A minus B, it would be cos A cos B plus sin A sin B. Look at this, don't get confused here. Whenever you have a negative sign here, you will have positive sign here. Whenever you have a positive sign here, you will have a negative sign here. So now, which is the next important formula? It would be tan of A plus B. That will be equal to tan A plus tan B, the whole divided by 1 minus tan A into tan B. Similarly, the next one would be cot of or tan of A minus B. Tan of A minus B will be equal to, we just have to interchange the signs from the numerator and denominator. What do we have here? Tan A minus tan B divided by 1 plus tan A into tan B. Now be very careful here. For cot, what happens is cot of A plus B will be equal to, look at this carefully, it's cot A cot B minus 1, it's not 1 minus cot A cot B, it is cot A cot B minus 1 divided by cot A plus cot B. Similarly, for cot of A minus B, again be very careful here, it's not here numerator, you can directly write it as cot A cot B plus 1, but then be very careful with the denominator, it's not cot A minus cot B, instead it is cot B minus cot A. Be careful with this, people. Few of you might get confused and write cot A minus cot B. No, it is cot B minus cot A. These are the very important formulas. So pause the video here, quickly write this down. From these formulas, we'll also be deriving many more formulas. So now concentrate, people. I told you that we'll be deriving other formulas using the main formulas that we wrote down here. What was the first formula that we wrote down here? It was sin of A plus B, that was equal to sin A into cos B plus cos A into sin B. Now we'll be using this formula to derive various other formula, which is that now instead of B here, if I take A, what will it be? Sin of A plus A, and this will be equal to sin A cos A plus cos A into sin A. Now what can I write this as? I can also write this as sin of 2A. That will be equal to, now what is this? Sin A cos A, sin A cos A. So I can write this as 2 into sin A cos A. Instead of A, if I take it as theta, what can I write this as? Sin of 2 theta will be equal to 2 sin theta cos theta. This is also one of the very important formula that we'll be using today. And then, now I can write this as equation 1. This is also an important formula. Now using this formula, we'll also derive another formula, which is that I'll take my left hand side to be the same. So sine of 2 theta will be equal to 2 sine theta into cos theta. Now what do I do is, I multiply my numerator and denominator with cos theta. So will the value of this change? No. Cos theta and cos theta will get cancelled, so this value will remain the same. But then instead of cancelling here, what I do is, I multiply it here. What I do? So what I'll be getting? 2 sine theta divided by denominator is cos theta into cos theta is nothing but cos square theta. So what can I write this as? I can also write this as 2 into what is sin theta by cos theta? Sin theta by cos theta is nothing but tan theta. And what can I write my cos square theta as? I can also write cos square theta as 1 by secant square theta. We know that cos theta is nothing but, secant theta is nothing but inverse of cos theta. So what can I write this as? 2 tan theta divided by secant square theta. We also know from the identity that secant square theta is equal to 1 plus tan square theta. So I can write my sin 2 theta as, sin 2 theta would be equal to 2 tan theta divided by, I can write my secant square theta as 1 plus tan square theta. So look at this, using one formula, we could derive other two formulas here. So both of these are very important. Sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta, as well as sin 2 theta is equal to 2 sin theta into cos theta. Both of these are very important formulas and we'll be using this in various conditions. Now we have derived few identities using sin of a plus b. Now we'll use cos of a plus b and try to derive other identities. So we need not do all this derivation in the examination. All we need is the final answer. We need to remember the final answer. The reason why I am showing you how to derive these formulas is because by chance you forget any of these formulas, you should be able to derive these formulas so that you remember these formulas better. So now we'll be using cos of a plus b formula. What is cos of a plus b? Cos of a plus b can also be written as cos a cos b. As I told you, whenever you have a positive sign here, we'll have a negative sign here. So it is cos a cos b in minus sin a sin b. Now similar to my previous problem, instead of previous derivation, instead of taking b here, I'll be taking another a here. So what will I be getting? Cos of a plus a, that will be equal to cos a into cos a minus sin a into sin a. So what I'll be left out? Cos of 2a will be equal to cos square a minus sin square a. This is one of the important formula. Don't get confused here, students. It is cos square a minus sin square a and not cos square a plus sin square a. Few students, what they do is, they take this value, they write this value as 1 because cos square a plus sin square a is 1 and cos square a minus sin square a is not equal to 1. So don't do that mistake. This is also a important formula here. Now what do? I take the same formula here, that is cos of 2a will be equal to cos square a minus sin square a. What I do is, I multiply the entire one and divide it by cos square a. Multiply and divide entirely by cos square a. So now what do I get? Here cos square a into cos square a becomes cos power 4a divided by cos square a. What will I be left out with? I'll again be left out with cos square a only. It will not make any difference here. Here what will I be left out with? I'll be left out with sin square a into cos square a all divided by cos square a. Now what can I write sin square a by cos square a as? I can also be writing it as tan square a. Look at this. What can I write cos square a as? I can also write it as 1 by secant square a minus sin square a by cos square a. Sin square a by cos square a can also be written as tan square a into, what can I write by cos square a as? Similar to this, I'll write my cos square a as 1 divided by secant square a. Now, if I simplify that, what will I be left out with? I'll be left out with cos 2a will be equal to 1 minus tan square a divided by secant square a. Taking the LCM and just subtracting it. So what can I write my secant square a as? In our previous condition, we saw that secant square a is also 1 plus tan square a. So what will be the value of cos 2a? Cos 2a will be equal to 1 minus tan square a divided by secant square a is nothing but 1 plus tan square a. And this will also be my important formula. And then, as I told you, we need to remember only these formulas. We need not remember any of the derivation. But then, for you people to understand how we arrived at this answer, I am showing you how to derive all these formulas. Now, I'll again make use of this formula and derive two more formulas. Which are those? Cos of 2a equal to cos square a minus sin square a. From our first identity, we know that cos square a is equal to 1 minus sin square a. So, cos of 2a will be equal to 1 minus, cos square a can also be written as 1 minus sin square a minus this sin square a remains as it is. So, if I simplify this, what will I be left out with? Cos of 2a will be equal to 1 minus 2 sin square a. Similarly, I'll use the same formula once again. That is, cos of 2a will be equal to cos square a minus sin square a. Now, we wrote cos square a in terms of sin square a. Now, what we'll do is, we'll write sin square a in terms of cos square a. From our first identity, what can we write sin square a as? I can also write sin square a as 1 minus cos square a. So, cos of 2a will be equal to cos square a minus 1 minus cos square a. So, what happens here? Cos square a remains as it is. If I take this negative sign inside, I'll be left out with minus 1, minus into minus plus cos square a. So, what can I write my cos 2a as? Cos 2a will be equal to 2 into cos square a minus 1. So, these are all the important formulas that you will have to remember, people. You will have to remember all these formulas. So, till now, we are done deriving identities using sin and cos. Now, what we will be using is tan. What can I write tan of a plus b as? Tan of a plus b, we have already seen in our today's session. Tan of a plus b is nothing but tan a plus tan b divided by 1 minus tan a into tan b. Now, what do I do here is, like in my previous derivations, instead of b here, I take this also as a. So, what will I be left out with? Tan of a plus a. Tan of a plus b will be equal to tan a plus tan a divided by 1 minus tan a into tan a. So, I can write this also as tan of 2a is equal to 2 tan a divided by 1 minus tan square a. Be very careful, people. What did we write sin 2a as? Sin of 2a was equal to 2 tan a divided by 1 plus tan square a. So the only difference between these two is this negative and positive sign here. So don't get confused with these two formulas. If you have negative sign in the denominator, it is tan 2a, and if you have positive sign in the denominator, it is sin 2a. So be very careful with these formulas here, because there's very small changes, so you might be getting confused. Till now we've already seen how to derive formulas for cos of 2a, sin of 2a and tan of 2a. Now we'll be looking at how to derive the formula for sin, cos and tan of 3a. What can I write my sin of 3a as? I can also write this as sin of 2a plus a. And look at this. This is of the form sin of a plus b. Instead of a, we have 2a here, and instead of b here, we have a. So what is the formula for sin of a plus b? It is nothing but sin a cos b, sin a cos b plus cos a into sin b. Instead of a, we have 2a here. Instead of a, we have 2a here, and instead of b, we have here a. So I've replaced b by a here and a by 2a here. So if I solve this, how can I write my sin 2a as? I can also write sin 2a as 2 into sin a cos a into, this is nothing but a here, into cos a, plus how can I write my cos 2a as? Cos 2a is nothing but 1 minus 2 sin square a into sin a. Now I have sin a in both the sides here, sin a and sin a. So I'll be taking that common. So what will I be left out with? If I take sin a common, I'll be left out with 2 into cos square a plus 1 minus 2 sin square a. Now, what can I write my cos square a as? From my first identity, I can also write cos square a as 1 minus sin square a. So if I replace this by 1 minus sin square a, what will I be left out with? I'll be left out with 2 into 1 minus sin square a plus 1 minus 2 sin square a as it is. Now if I multiply this, or if I solve this, what will I be left out with? Sin a into 2, I'll take 2 inside, what will I be left out with? 2 minus 2 sin square a plus 1 minus 2 sin square a. Now look at this, minus 2 sin square a minus 2 sin square a will give me minus 4 sin square a. 2 plus 1 will give me 3. So sin a into 3 minus 4 sin square a. If I multiply this inside, what will I be left out with? I'll be left out with 3 sin a minus 4 sin cube a. So, and this will be the formula for sin 3a. Sin 3a will be equal to 3 sin a minus 4 sin cube a. And you'll have to remember this formula, people. So now we are done deriving for sin of 3a. So next, what we'll be deriving the formula for? We'll be deriving the formula for cos of 3a. How can I write my cos 3a as? I can also write my cos 3a as cos of 2a plus a. Now carefully observe this. This is of the form cos of a plus b. Now what is the formula for cos of a plus b? It is nothing but cos a cos b, cos a cos b, minus, whenever you have positive sign here, it is negative in cos of a plus b formula, minus sin a sin b, sin into 2a, sin of a. So now, what can I write my cos 2a as? I can also write my cos 2a as 2 cos square a minus 1. whole into cos A minus, what can I write my sin 2A as? I can write my sin 2A as 2 sin A into cos A into sin A. Now look at this, we have cos A common in both the terms here. So what I'll be doing is I'll be taking cos outside. So what will I be left out with? If I take cos A common, I'll be left out with 2 cos square A minus 1 minus 2 sin A into sin A will be nothing but 2 sin square A. Now once again, from our first identity, what can I write my sin square A as? I can also write my sin square A as 1 minus cos square A. So this will be cos A into 2 cos square A minus 1 minus 2 into 1 minus cos square A. Now if I simplify this, what do I get? Cos A into 2 cos square A minus 1 minus 2 minus into minus plus 2 cos square A. So now if I bring my cos inside, what will I be left out with? 2 cos square A plus 2 cos square A will give me 4 cos square A. 4 cos square A into cos A will give me 4 cos cube A. Now here minus 1 minus 2, so it will be minus 3. If I get my cos A inside, I'll be left out with 3 cos A, and this will be the formula for cos 3A. And you people once again need to remember this formula. So if you are not able to remember this formula, use the derivation that I've used here. Try to understand how we arrived at this formula so that it will be very easy for you people to remember this formula in the examination. Now we are done with sin of 3A and cos of 3A. So which is the next one? It is tan of 3A. What can I write my tan of 3A as? I can also write this as tan of 2A plus A. Again, this is of the form tan of A plus B. We all know that tan of A plus B is nothing but tan A plus tan B, the whole divided by 1 minus tan A into tan B. Now, we know that what is the formula for tan 2A? We know I can also write my tan 2A as 2 tan A divided by 1 minus tan square A. Once again, I am repeating people, careful here. If it's 1 plus tan square A, it would be sin 2A. So it is 1 minus tan square A plus tan A, the whole divided by 1 minus, once again, tan 2A can also be written as 2 tan A divided by 1 minus tan square A into tan A. Now if I simplify this, what will I be getting? I'll be getting 2 tan A 2 tan A. If I take the LCM here, I'll be getting minus 2 tan A minus tan square A. Sorry, tan A 2 tan A into 1 tan A into 1 minus tan square A. I'll be left out with 2 tan A minus, plus tan A minus tan cube A. The whole divided by 1 minus tan square A. 1 minus tan square A. Similarly, what will I be left out in the denominator? If I take the common here or take the LCM here, what will I be left out with? 1 minus tan square A minus 2 tan A into tan A is nothing but 2 tan square A divided by 1 minus tan square A. 1 minus tan square A on 1 minus tan square A gets cancelled here. So what will I be left out with? I'll be left out with 2 tan A plus tan A is nothing but 3 tan A minus tan cube A. The whole divided by 1 minus tan square A minus 2 tan square A. I'll be left out with 1 minus 3 tan square A. And this is nothing but tan of 3A. So as I told you, we'll have to remember this formula here. So what is tan 3A? Tan 3A is nothing but 3 tan A minus tan cube A divided by 1 minus 3 tan square A. So pause the video here, quickly copy all this down. Once you're done copying, we'll be seeing other formulas that we'll be deriving using the same 6 formulas that we wrote down in the. So now we are done for sin 3A, cos 3A and tan 3A as well. Now what we'll be doing is, we know that sin of A plus B is equal to sin A into cos B plus cos A into sin B. Similarly, we also know that sin of A minus B will be equal to sin A cos B minus cos A sin B. So now, what if I add these two? What will I be getting? If I add these two, I'll be left out with sin of A plus B plus sin of A minus B, and that will be equal to, since it is addition here, sin of A plus A, sin A cos B plus sin A cos B will be nothing but 2 sin A cos B plus and minus cos A sin B gets cancelled. So I'll be left out with sin of A plus B plus sin of A minus B will be equal to 2 sin A into cos B. Similarly, now what if I subtract these two instead of addition? What if I subtract here? The sign changes throughout. This will be negative and this will become positive here. So what happens? Sin of A plus B plus sin of, sorry, it is subtraction now, we are subtracting now. So it is minus sin of A minus B, and that will be equal to, look at this, sin A cos B and minus sin A cos B gets cancelled. So here now we have both positive terms. So we'll be left out with 2 into cos A sin B. So if we add both sin of A plus B plus sin of A minus B, we'll be left out with 2 into sin A cos B. Now if we subtract those two, we'll be left out with 2 into cos A sin B. Now in these formulas here, what if I take A plus B as alpha and A minus B as beta? A minus B as beta. Now what will be the value for A here? How to get the value for A? Now if I add these two, what will I be left out with? If I add these two, I'll be getting 2A, that will be equal to alpha plus beta. Then what will be the value of A? A will be equal to alpha plus beta divided by 2. Similarly, now if I subtract these two, what will I be left out with? This will be negative here, this will be positive, and this will be negative. So what will I be left out with? A and A gets cancelled. 2B will be equal to alpha minus beta. And what will be the value for B? Value for B will be alpha minus beta divided by 2. Now if I replace the same thing in this formula, what will I be getting? Sin of, I'll be getting sin of A plus B. A plus B is nothing but alpha. Sin of alpha plus sin of beta will be equal to 2 into sin of A. Value for A is alpha plus beta by 2. Alpha plus beta by 2 into cos of alpha minus beta by 2. Similarly, if I replace the same thing in this equation, what will I be getting? sine of alpha minus sine of beta will be equal to 2 into cos of alpha plus beta by 2 into sine of alpha minus beta by 2. So these are all the important formulas that you will have to remember. So you'll have to remember all these formulas, people. We'll be using all these formulas in one or the other problems. So try to understand how we have derived all these formula so that you will remember all these formulas easily. Now we are done for sine of a plus b and sine of a minus b. Now what if I write the same for cos of a plus b and cos of a minus b? What is the value for cos of a plus b? Cos of a plus b can also be written as cos a cos b minus sin a sin b. So now what can I write my cos of a minus b as? My cos of a minus b is equal to cos a cos b plus sin a sin b. So now if I quickly add these two, what do I get? I get cos of a plus b plus cos of a minus b will be equal to 2 into cos a cos b, 2 into cos a cos b, because sin a sin b minus sin a sin b plus sin a sin b gets cancelled here. Now what if I subtract these two equations? What do I subtract? So now watch this carefully. I'll not be subtracting cos of a minus b from cos of a plus b. Instead, I'll be subtracting cos of a plus b from cos of a minus b. If I subtract cos of a plus b from cos of a minus b, what will I be left out with? So here it will be negative. So this will be negative here. This will be negative and this will be positive here. So what happens? Cos of a minus b minus cos of a plus b will be equal to negative cos a cos b, and cos a cos b gets cancelled. So what will I be left out with? I'll be left out with 2 into sine of a into sine b. So now similarly, like what we did for the previous derivation, if I take a plus b as alpha and a minus b as beta, so what will be the value of a? We've already derived. A will be equal to alpha plus beta by 2. Now what will be the value of b? B will be equal to alpha minus beta by 2. So now if I quickly replace all this in this equations, what do I get? Cos of a plus b, that is nothing but cos alpha, plus cos of a minus b, that is nothing but cos beta, and that will be equal to 2 into cos of alpha plus beta by 2 into cos of alpha minus beta by 2. Similarly, if I take cos of alpha minus cos of beta, that is nothing but cos of a minus b. Sorry, it is nothing but cos of beta minus cos of alpha, cos of beta. So it is nothing but cos of beta minus cos alpha, and that will be equal to 2 into sin a sin b, that is nothing but 2 into sine of alpha plus beta by 2 into sine of alpha minus beta by 2. So quickly pause the video and copy all this down, people. These are all the important formulas that you should be knowing before we start solving problems on trigonometry. So this will be the end of our session today. In today's session, we have derived almost all the formulas that we'll be using in our next classes. So what I want you people to do is, I want you people to derive all the formulas on your own and memorize as much as possible and come to my next class.